This is Pythagoras theorem, and you probably have heard it in your trigonometry or geometry classes. But have you ever wondered how it is driven? If no, then this video can get you covered. For starters, we have a line segment, an arbitrary line segment, and we will divide it into two segments, let's say A and B. And we will just copy and paste it to make a complete square with the same ratios as the previous line segment. So here we have our previous ratios, and now what we're gonna do, we will gonna make another line segment joining the breakpoints which are between A and B, like this, and let's call it C. Again we will copy and make another square, this time a smaller square, which will be inside the larger square. And you might have noticed that now we have a larger square, a smaller square, and four right triangles around the smaller square. So now let's talk about the geometry. So we have two squares and four right triangles. The larger square has length A plus B, as we can see that, and the smaller square has length C, and each right triangle has a base and an altitude A or B. I'm using the word or because we can interchange in both of them, as you can see in the following figure. Here we have A as a base and B as a perpendicular. B is a base, A as a perpendicular, again B as a perpendicular, and A as a base, A as a perpendicular, and B as a base. So we can interchange in A and B. So now let's talk about the area of the larger square. We know that the area of a square is length times length, and length is square. So we can say that the area of the larger square is A plus B whole square, because the length of the larger square is A plus B, and the area of a smaller square will just C square. Area of each right triangle will be half times A times B, or half times AB. Hence the area of four right triangles. So what we're gonna do, we will just multiply the area of each right triangle by 4. So we will have 4 times half of AB, which will leads towards 2AB. Now finally we have all the ingredients prepared for our theorem to be driven. So what we are going to do, we are going to observe that as you can see that the larger square contains all the other shapes, like the smaller square and the four right triangles. So we can say that the area of the larger square is equal to the sum of the area of a smaller square plus area of four right triangles. By substituting the values A plus B whole square in place of area of larger square, C square in place of the smaller square's area, and 2AB in place of area of right triangles. So here in the left hand side we have A plus B whole square, which can be further expanded into A square plus 2AB plus B square. So by cancelling 2AB from both the sides, we will be left with A square plus B square equals to C square, or we can say that C square is equals to A square plus B square. Notice that C here is a hypotenuse in each and every case, but A or B, they both can be interchanged. So we can write our formula as hypotenuse square, which is C square, perpendicular square, which can be A or B, plus base square, which can be A or B, as both the values are just adding up. So this will leads towards the hypotenuse square, and this is the final derivation of the Pythagoras theorem. And I hope you guys liked it, so give it a thumbs up, and I'll see you next time.